All right. So today we're going to learn our second method. So the first method we learned was, what was the first method? Oh, graphing in tables. Okay, so the first method we learned was graphing in tables. And that method involved us just looking at pictures. So now we're going to actually start learning mathematic methods. Now I'm going to tell you why all of this works, but if you don't understand it, it's okay. Some people are like, I have to understand why it works in order to be able to understand that it works, like whatever. So I'm going to tell you why it works, but if you don't get it, it's okay. I didn't really get it for a long time, and I was still able to do math pretty good. Okay, I didn't understand half of what I was doing or why I was doing any of it. I just knew that it worked, and that's all I cared about. Okay, so, but I am going to tell you why this method works, just for those of you who need that kind of understanding. Okay, so I want you to write down zero product property. Okay, the reason this works, you're done with that now, by the way. The reason this works is because of the zero product property, okay? And what the zero product property says, here, let me just zoom in and we'll pull this over here. Okay. Okay, I don't know what I just started to write there. Okay, when the product of two factors is equal to 0, when the product of two factors is equal to 0, one or more of the factors must also equal 0. So when the product of two factors is equal to 0, one or more of the factors must also equal 0. Okay, so that's a lot of pretty words. Let me tell you what they mean. Okay, so I'm going to give you some examples. You don't have to write these down unless you want to. Okay, so 2 times something equals 0. What does that something have to be? 0, right? Because the only way I can get 0 is by multiplying a number by 0. That's the only way I can multiply and get 0. Okay, so what if instead I had 2a equals 0? What does a have to be? 0. What if I had a times b equals 0? One of them has to be 0, right? Do I know which one? No. So either one of them could be 0. So A could be 0 or B could be 0. Because I don't know. I know one of them has to be 0. So A or B or both. But one of them has to be 0. Okay? And that's what property we're going to use to allow us to be able to find solutions mathematically. Okay? We're going to find out what our factors are. I'm going to kind of go into this a little more. Let's start by factoring this first problem, and then this will start to make a little bit more sense, okay? So let's start with this one. So if you look at the bottom here, it says you always check for a GCF first, solve by setting equal to 0, but you actually do this backwards. You solve by setting equal to 0, and then you look for a GCF. So let me explain what this means down here, okay? When it says we solve by setting each factor equal to 0, let's say I had this, 3x squared plus 13x minus 2 equals 8. Let's pretend I had that. The zero product property is not going to work here because this does not equal 0. So if I factor this, it's not going to help me because it has to be equal to 0 before I can actually use this property. So in order for me to solve this by factoring, I have to set this equal to 0 first. So how do I get this whole thing equal to 0? I'm going to subtract 8 from both sides, which means this equals 3x squared plus 13x minus 10 equals 0. Now, do I have a 0? So now if I factor this, my two factors will be equal to 0, and I'll be able to use them to solve. So this, if it's not already equal to 0, I have to set each factor equal to 0. And that's what that would look like. Okay? All right, so what I want you guys to do, I want you to factor this guy up here. The one that says two solutions. 0 equals 3x squared plus 13x minus 10. Do I have a GCF? No. So I can jump right to the box and start factoring it. I want you guys to factor it right now. And I will also factor. But remember, we learned how to factor on the last test. That's why this unit is so short, because we expect that you already know how to factor. Okay? So the expectation is you've already learned how to factor. We're just adding one step to it. So if you don't know how to factor, you have got to come to tutorials on Wednesday. Okay? Now remember, you can use your calculator. And you can do the, in y1 you would put a times c divided by x, and in y2 you put y1 plus x. Okay? So you can do that. Huh? It's on the board. A times c divided by x, y1 plus x. Okay? Okay, I can give you about 30 more seconds to solve this. And again, if you're looking at my work, and only looking at my work, that's kind of a problem. Next problem, I'll wait to do my work until after you guys have started. Raise your hand if you need more time. Okay, I'll give you 20 more seconds. Okay, so when you factored this, you should have gotten 3x minus 2 and x plus 5 as your two factors. Okay, so remember back up here when we talked about our zero product property. We said that if there's two things that I multiply together to get 0, that one or both of them have to equal 0. So let's just pretend, what if this first one, this 3x minus 2, was the one that equaled 0? What would x have to be? Well, no, 3 times 0 minus 2 gives me negative 2. So nope, 3 times 2 is 6 minus 2 is 4. Well, couldn't I just solve the equation, right? So 3x minus 2 is 0. Then if I add 2 to both sides, I get 3x equals 2. Divide both sides by 3, and I get x equals 2/3. So if x is 2/3, 3 times 2/3 is 2. 2 minus 2 is 0. That makes this thing 0. So this one will be 0. 2/3 plus 5 is 5 and 2/3. 0 times 5 and 2/3 is 0. It works. Okay, great, it worked. So one of them was 0. Okay, well, what if that one wasn't the one that was 0? What if this one was 0? What if the x plus 5 was the term that equaled 0? Well, I can solve that too. I subtract 5 from both sides. I get x equals negative 5. So 3 times negative 5 is negative 15. Negative 15 minus 2 is negative 17. That's not looking good. So that will be negative 17. Negative 5 plus 5 is 0. Negative 17 times 0 is 0. That one works too. So those are my two solutions, because they both make the equation true. Now, some of you may be like, I don't believe you, Mrs. Deal, and that's okay. You don't have to, because here, look. It's true. X equals negative 5 and x equals 2/3. There it is, right in my calculator. Okay? So this is mathematically what we were doing with our eyeballs yesterday. But can I look at this and tell that it's exactly 2/3? No. It's not really clear exactly what it is. So this allows me to get a precise answer for one of these. Okay? Now, this only works if I can factor the problem. If I can't factor the problem, I can't get the solution. Okay? Let's pause for a second. What questions do you have about that? The only reason that this worked is because it was set equal to 0, and the zero product property allowed me to set each factor equal to 0. Okay? If it wasn't equal to 0, none of this would have worked. Okay? What questions can I answer? You guys want to try another one? See if you got it? Okay. Let's take a look at the second one. Now, I'm going to have you do the second one by yourself, but I want to talk really quickly about the GCF. Because the GCF behaves a little bit differently with an equation than it does with an expression. So if there was no equal sign here, right, I would factor out the GCF, which is what? 2. And I would say 2 parentheses x squared plus 6x plus 9. Okay? But since this is an equation, when I divide all of these terms by 2, I have to divide the left side by 2 also. What happens to the 2? I'm solving an equation. The 2 disappears. The 2 goes away when I'm solving. Because remember, when I solve an equation, I do the same thing to the left as I do to the right. The 2 disappears. 0 divided by 2 is 0. 2x divided by 2 is x squared. 12x divided by 2 is positive 6x. 18 divided by 2 is positive 9. So in this way, the GCF behaves differently when I'm solving than when I'm just factoring. When I'm factoring, I have to keep the GCF. When I'm solving, the GCF kind of goes away, as long as it's a number. Now, if the GCF was a letter also, then that would be different. I would actually have to solve it. Then I would have 3 solutions. That would be a cubic, and why would we be doing that? Anyway. Okay, I want you to factor this one. Okay, factor this one. I'm going to give you all a 2-minute head start. You already did? Did you already solve? Did you see the pattern? You all are looking like you're a little bit more done than I thought you would be. I'm going to go ahead and start solving this one so you can see if you want to. Okay, is this what y'all got? Yeah. Did anybody see the pattern? Yeah. Did anybody catch that it was a PST? Okay, if you didn't, that's okay. It's okay. If you can see the pattern, that's great. But again, I'd say I'm 50-50 on catching it. I don't always catch that pattern either, so I mean, don't feel bad if you didn't catch it. I'd say half the time I don't notice it either. All right. Okay, so when I set these equal to 0, right? So since I know that one of these has to equal 0, I'm going to set them both equal to 0. And then I'm going to solve. The first one when I solve, I subtract 3. I get x equals -3. But isn't the first one and the second one exactly the same? Yes. Yeah. I don't need to do that work twice. I'm going to get the same answer. I mean, if I subtract 3, I get x equals -3 again. I don't need to say it twice. So I have one solution at x equals -3. What must that point be?
The vertex.
Why does it have to be the vertex?
Because it's the only It doesn't have a symmetrical pair.
It's the only point, very good, it is the only point on my parabola that does not have a symmetrical pair. So when I only have one solution, that means the solution is the vertex. Okay, that gives me another useful piece of information. So I can visualize what that graph looks like. If I only get one solution, I know that the vertex has to either be sitting on the x-axis pointing up, or the vertex has to be hanging off the x-axis pointing down. Because this is going to be my minimum or my maximum, because the only way, that's the only thing on a parabola that I've only got one of, is the vertex. Okay? What questions? So are we okay with why there's only one solution here? Because I get the same answer twice. I mean, there's only one. Okay, I want you guys to try factoring this last one. Doesn't have a GCF, and it's set equal to 0 already, so we're good to go on that one. Okay, so what'd y'all get?
Nothing.
Can you factor it? No, it can't be factored. That means there are no real solutions. Now, there are solutions, you just don't have the math to find them yet. Okay? So, and again, the reason why this happens is because x squared minus 4x plus 5, it's a perfectly lovely parabola, but it never hits 0. So it doesn't have any solutions. What else would we call this solution? What else would we call something that had, what do we call, okay, it doesn't have any solutions. What else doesn't it have? Zeros, roots, x-intercepts. Okay? So when the solution I'm looking for is 0, I also call that a root. I call it a x-intercept. I call it a 0. Those are all kind of synonymous. They're used in different situations, but they're synonymous. Okay? What questions do you guys have about this process? Is it pretty straightforward? Okay, great. Turn the page. Okay, special factoring. Ooh, special. Yes, I know. Special factoring. Okay. So, remember we have our two special factors. Now, these are, I put them in your book, but remember, they're on your formula chart. You don't have to memorize these. You don't have to, you know, they're on your formula chart. Okay? So, dots always results in two solutions. Always. So, when you see something that's a difference of two squares, you're going to have two solutions. Okay? Dots is a pattern that you guys were good at. Y'all were good at dots. Okay? So, how do I do dots? I find the square root of the first one, which is what? X. What about the last one? Okay, so now what am I going to do? I'm going to do one's plus and one's minus. So x in the front, 7 in the back. Put a plus in one and a minus in the other. And that one is equal to 0. And again, with this one, they also have to be equal to 0 because this is a factoring method. Okay? They all have to be equal to 0. Well, there's one method that they don't have to be equal to 0, but that's something else. Okay. Yeah. Okay. So what am I going to do with these? Set them equal to 0 and solve them. So let's do that. And I'm pretty sure that dots is always, the solutions are always opposite each other. Yeah, they would have to be, because B is what shifts it left or right. So yeah, the dots, the solutions are always going to be opposites, meaning they're opposite each other. So whatever you get, the solutions are going to be opposite each other. Because dots are always going to be, dots, difference of two squares, they're always, the vertex is always on the y-axis. So it's not shifted left or right from the y-axis. It's always right, right on the y-axis. Okay? What do y'all think? Easy? Okay, I want you to use the pattern to factor the next one and find the solution. Again, if we can use the pattern, use the pattern. I mean, don't stick it in a box. We don't have time for that. You could. And you'd be looking for B to be 0. But it just takes longer. Like if you memorize the pattern, it's easy. When you're ready, but not until you're ready, check and see if you got the same thing I did. Okay. Remember how at the beginning of the year I was like, yeah, we got to show our process, and y'all are like, I can do it in my head. Great. Okay, see, it's all coming back. Everything we did before, we're going to keep doing. This is just simple solving equations that y'all did in 6th and 7th grade. Here it is. Okay. You do have the math to do this. Okay. Now, would I accept 1 2/3 and negative 1 2/3?
Yes.
Yeah, totally. Would I be as happy about 1.67 and negative 1.67?
No.
No, because they're not terminating decimals. Now, you can still put them, but I want you to be aware, I try to only go as far as precision allows me, because I don't know what the question is going to look like on a test, but I know that 1 2/3 is probably about as simplified as I can make it. You can leave it as 5/3, I'd be fine with that, but 1 2/3 is going to help you more when you're looking at a graph. Okay? Questions about that? Okay, dots is the easy one. PST is the one that y'all did not seem to be super stoked about. Okay, so let's talk about PST. The PST pattern. For the PST pattern, what I'm going to do is I'm going to take the square root of the first term and the square root of the last term. And again, I would say I'm 50-50 on actually noticing this pattern. So if you don't notice it, it's okay. You can still factor it with the box. But if you do notice it, it's a quick factor, okay? So I'm going to look at, I know that I'm onto something with PST because the first and the last terms are perfect squares. If they're not perfect squares, it's not what I'm looking for, okay? Now, what I do, in order for me to prove that this is a PST, the square root of the first one times the square root of the last one times 2 should equal what's in the middle. 10 times 2 is 20 times x is 20x. Yes, this is a perfect square trinomial. You just have to multiply, you have to double it. Yeah. I actually got 2 from right there. From the formula chart. Okay? So you have to double it. Then just factor it. Okay? And then once I have that, I put the square root of the first number in the front, the square root of the last number in the back, and whatever the sign is in front of B, that's the sign I put between them. Exactly. So like you see down here on the bottom one, since it's minus, you'd have a minus between them on that one. Okay. So now, what do I do? Now, do I have to do it twice?
No.
No, because I know it's going to have one solution. Because even if I solve it twice, I'm solving the same thing twice. It's not a good use of my time. Huh? I'm sorry, that should be a 0. I don't know what happened there. Sorry, I lost my mind there for a second. And that's the only solution I've got. Why did I put 2 there? I don't even know. What is that? I'm sorry, internet people. Okay, so what do we think? Okay, I want you guys to try the bottom one. And even though I'm telling you this is a perfect square trinomial, I want you to do that same, square root of the first, square root of the last one, doubled, and confirm that it's a perfect square trinomial. I'll give y'all another 30 seconds or so. Ooh, this video is long, y'all. But it's only if you need it. All right, so why am I okay with 4.5 this time? It's a terminating decimal. It doesn't go on forever. It's not non-terminating. It terminates. It's 0.5. Boom, I'm done. I don't have to round anything. I don't have to do anything weird. It's just 0.5. Okay? What questions can I answer? All right.